Appreciate you, I guess, leading off, Tim. That helps out quite a bit. It kind of gives us a baseline to go on for drone operations, and I appreciate the ARC Forum for allowing us to come and speak today. What I'm going to talk about, and first off, I'm Drew Talley. I'm the Field Operations Manager for Aerial Production Services, so I manage all the oil and gas operations for that company. We're going to talk about creating a digital twin of a complex asset, much like this compressor station that you see here, but we're going to go a little bit deeper than that. We're not going to talk about the software that's required to create digital twins and modeling, things like that. We're going to talk about the capture portion of it. How do you seamlessly capture these 3D point clouds, and how do you get it into a usable form that some of the software that, like the Bentleys and other software providers here at this conference, utilize this type of data. Before we get into that, let's talk a little bit about aerial production services. Of course, we're a drone service provider, but we tend to not consider us as just a drone service provider. We go out and research the best sensors, the best drones, the best technologies, whether it's ground-based sensors or aerial-based sensors, and find a way to deploy it for our customers' problems. We look for, what answers are they trying to find, and what sensors can we provide a customized solution to help answer those questions. So we were established in 2014. We've flown 35,000 plus sites in 49 states. We're honestly still trying to get to Hawaii, but we can't justify the cost to fly a pilot out there right now. So maybe next year we'll get to it. We service three major verticals within aerial production service. That's cell tower, construction, and oil and gas. And within the oil and gas, what I'm seeing is our customers are increasingly seeking to digitize their assets. They're looking to figure out how do we utilize these point clouds to gain insights into the conditions of their assets, the conditions of their site, monitor changes over time on whether it's a facility, they're adding new equipment to it, the as-builts that they had for it have changed. How do you keep up to date with all of those things? Or in North Dakota, we have snow melt every year. Well pads, they change. The erosion that happens on those, they need to stay up to date with it so that they can deploy their technicians to fix those problems in a timely manner and triage it to figure out where to send their assets first. It improves the decision making. You can make these decisions from an office instead of sending a guy out to the field to collect this data and then come back, make a decision on what you're going to do, then send the guys back out there. So you're reducing windshield time. But collecting this data, it's hard. It's not easy. It's to get good data for our customers to be able to use them in gain the proper insights from them instead of just throwing them a point cloud and saying, here you go, good luck. And our customers are like, well, what do we do with it? So there's challenges, but there's also opportunities to deploy customized or different types of sensors to collect this data. We'll talk a little bit about a gas compressor station that we captured about a year ago. It's not super complex, but it is complex. I mean, we've got some pipeline, we've got a co-located valve station, we've got cooling towers, separators, we've got compressor skids, we've got compressors inside of a building, and a lot of piping that's related to this compressor station that's outside. It can be difficult to be able to capture piping from a LiDAR perspective. Being able to capture it fully, it's quite difficult. So this customer came to us and asked us, scan the site for us, both indoors and outdoors. We want above, below, between. We want a full picture of our entire compressor station. We don't want any gaps in the data. And we don't want you to get in our way. We don't want you to shut down our plant. We don't want you to mess with our operators. We want you to get in and get out and give us this data. And we said, okay, we'll find a way. How do we do that? So terrestrial LiDAR. We've used that before. Everybody have seen ground-based LiDAR scans. They can be time-consuming. They can, you got to get closer to the equipment. If you want to get above stuff, you got to get a scissor lift and put one of your operators in a hazardous situation to capture some of that data. We can do it, but is it the best answer? Maybe. And we're a drone company, so we thought about, well, let's utilize a aerial-based LiDAR. Does that fit? Well, yeah, it can. We can get the roof. We can get all of the above ground assets, and outside we can see all of it, but we can't see underneath anything. So we were like, well, maybe it's a combination of terrestrial LiDAR scanning and an aerial LiDAR scanning, put them together. We've got to use one software to process the ground-based terrestrial LiDAR. We've got to use another software to process this other one. We've got to find a way to merge them together and make them fit right. So we were like, well, we've got another technology out there, SLAM-based LiDAR, which Tim mentioned earlier, simultaneous localization and mapping. We use this in our company for under-bridge pipeline inspections. We need to be able to get underneath a bridge where it's a GPS-denied environment and put our drone in a position to be able to inspect that pipe properly without, the risk of running into the bridge or crashing a $100,000 drone and, not being able to complete it for a customer. We've got to eliminate those risks so that we can do that. So we put a SLAM-based LiDAR on there, which can build the environment around it and then create a safe space or a shield around the drone so that operator error isn't of concern. You don't have to worry about, a pilot that's thinking about getting into a better position to get a better angle on the pipe to get that certain picture, and he goes up stick too much and tries to fly it into the bridge. The majority of problems or the crashes in the drone industry is pilot error. It's not hardware. So eliminating that pilot error is crucial to us. The speed of data capture. SLAM allows us to not, beforehand sit there and try to plan a route above a compressor site to be able to capture all of it and then look at the data and say, oh, I didn't capture something. Real time, we can fly this around, look at the data on a screen and make decisions. Our pilots can make quick decisions. Oh, I need to get this other angle. I'm missing a part. I'm having some shadows in my LiDAR data. So we're able to create a dense shadowless point cloud with the Emison hover map system. So we went with that. We mounted it to a DJI M300 drone. We used the pilot assist mode. With the pilot assist mode, they have 3 different modes on this. You can fly it as a dummy payload. You can fly it as what we can call mode 1, where we are creating that shield around it. We're eliminating pilot error and the risk of running into anything. Or they've got a mode 2 where you can fly this completely autonomously. You can pick a point in space and say, fly there, but don't hit anything. And the drone with the Emison LiDAR system on there will fly to that point, create a picture of what they're seeing, come back, show you what they're seeing, and then you can make decisions to continue like they use in Australia. They use it for stope inspections and mining. They're able to send it into hazardous situations autonomously, have it capture that data, bring it back to you and show you what it's seeing so that you can make follow-on decisions. And of course, we can capture data with the hover map system in hours rather than days if we were doing a terrestrial scan. So getting back to the compressor station, we were able to capture this entire compressor station with just 2 25-minute flights and, of course, a 20-minute ground walking. We can take the hover map system off the drone and actually walk it around, or we can attach it to a vehicle and drive it around. It's a very versatile tool for us. So, of course, with this example, we don't have the interior of the compressor station. We couldn't get them to approve showing that off or anything, but what we're seeing here is what is approved. 2 25-minute flights and a 20-minute walk. That's, 70 minutes. Versus if we were to do this with a terrestrial scanner, I'm looking at least at least 150 different scan locations at 4 to 7 minutes per scan. And that's not including me having to continuously move this piece of equipment around. So we're talking about days of inspection versus a few flights. We also eliminated the need to have our personnel get real close to the equipment. We could fly the majority of this from 100, 200 foot off. We didn't have to get close to the equipment. We eliminated the need of our employees having to get into hazardous situations to capture this data. Limit the time. That risk mitigation is what drones are all about. I mean, getting people out of harm's way. So what we did is, in utilizing this system, is we reduced risk for our operations team. You know, that's from my perspective, from the drone service provider and managing all these operations, that's key. Safety is number one for us. But we also we cut our inspection time by utilizing the right tool for the job by 80%. We reduced our post-scan processing time by more than 40%, and I could probably argue that it's a lot more than that, because while we're out in the field, we're continuing to capture more things past just the point cloud. So we're going to go capture valve information, valve manufacturer information. We're going to capture pictures of welding locations and taps and different information that we're going to supplement the point cloud with to create a full picture, a digital twin that our customers will need. So while we're capturing all of that, we're processing it on a standard laptop in our truck. By the time we're finished capturing all the information, all the pictures, the same day, we're able to look at that point cloud. Those 3 different scans, we've already processed them. We've already merged them. We're able to look at an unclean point cloud on site so that our pilot and our VO, they can look at it and say, okay, maybe I missed something over here. I might need to go do another flight real quick to capture that, so that from my perspective, I don't have to, bust my budget by sending them back out there for another day to do this, because what we're doing with drones is we're driving down cost. We're not taking 3 days to capture this, 3 days of man hours on my part that, of course, I've got to charge my customers. So we're driving down cost, and we're doing it because we can use one single versatile tool. And switch gears a little bit. I think I hit the... Switching gears just a little bit, the point clouds, they're all pretty. Everybody loves it. Everybody loves to see a little point cloud and, oh, this is cool, and, circle around inside of your little viewer. But what do you do with it? Do you make a CAD drawing of it, a simple little CAD drawing? Do you model it past this? Do you add, not sure if the video's, okay. There was a little video attached to it and about 4 more slides, but. Oh, well, I guess you don't have the rest of the slides, but we'll just ad lib. The other things that you can do with it is you can supplement these with like leak detection data. We do a lot of drone leak detection within aerial production service. So we'll go out and we'll capture say a well site, and we'll take all the information from that well site, whether it's the well names, the tanks, the separators. We'll digitize it, and then we take all the information that I was talking about earlier. Maybe it's the manufacturer of a Nardo valve or a thief hatch on top of a tank. We'll take that and pair it with that point cloud data in a GIS form, so that our customers are able to see the GPS locations of all of their assets, and then the inspections that go with it, the inspection data from either leak detection or a visual inspection or corrosion inspection. We had some slides of a flare stack inspection that was completely digitized, that had a refractory casing crack on it. We can measure the refractory casing crack that has some buildup on the flare tips, had some corrosion on the line going up to it, and then on that same site had a major severe leak going on. So we were able to look at a whole well site holistically from from a 20,000 foot view from the office. You didn't have to send personnel out there to look at that. You can look at it from the office and decide, okay, well, there's more going on here than what's at face value. Maybe the equipment's operating just fine. Maybe the separator is just venting off like it's supposed to and we've seen some leaks, or maybe it's dumping straight to the tanks and we need to get an operator out there to do this certain thing to fix it so that the separator's not dumping straight in. Maybe we got too much pressure on the lines. Who knows? They can make those decisions from the office and deploy the field personnel with the knowledge to do what they need to do without having to go out there, assess, come back to the office, pick up more tools, or look at some more drawings, and then go back out into the field and fix it. They need to be able to deploy with the knowledge in hand. And that's what this LiDAR data helps us do. You build that whole picture for our customers utilizing the right tools. Thank you.